Okay, today's lesson is Unit 1, Lesson 10, and we are talking about exploring inequalities. So I hope you remember you've been doing this, but you have only been doing it on a number line. But what you did is it involved this symbol, which is less than, greater than, or less than. And you also need to remember that whenever you think about that and you think about graphing, that there will always be some type of shading involved in your graph. Okay, so the problems that I want to work together, starting down at the bottom of the first page, we have one that looks like this. It says, graph y is less than negative x squared plus 4 on the coordinate plane. So you should have your packet out if you're not familiar with this, but hopefully you are. So this particular equation, okay, when you graph it, you're basically ignoring the inequality first. So we're looking at y equals negative x squared plus 4. Okay, what is that? Now from your parent function packet, we should know that that is y equals x squared, which is your quadratic equation. Okay, and that quadratic equation looks like this. That's the key. The parent function is what we call it. And this point right here, which is that vertex, is what I put up at the top as 0, 0. And that's because that's kind of that starting point. And then when we have other things added to that equation, then we talk about how it moves around. And then we had some key points that we discussed, and those key points were 1, 1, 2, 4, 3, 9. Now, where do those come from? 1, 2, 3. If you square each of those, you will get this number. Okay? So if you had to continue, if you had 4, I hope you're telling me that that would be 16. Okay? Now, how are we going to use that? Watch this. Okay? So what we're going to do here, we have our parent function of y equals x squared, and now we're looking to graph y equals negative x squared plus 4. So you know from that first test that this negative is flipping over the x-axis. And if it's flipping it over the x-axis, same thing as opens down, if you want to think about that. On a parabola, that's the only thing we can say that with. And this 4 moves our graph up 4 units. Okay, so to go graph that, let's go back to, so normally we would start at 0, 0, and we would go up. Okay, before I do that, it's important to understand there are two operations. Okay, this right here is multiplying by a -1. This right here is adding 4. And in our order of operations, we do multiplication before addition. So you always want to do that first, which is flipping it before you move it. So originally it would go up. Now it's going to go down. And that 0, 0 point is going to move up 4. So my starting point is right here. And then what this represents right here is a rate of change. And yes, this is like the x and this is like the y, which means horizontal and vertical. So from this point, if I go over 1, I'm going to go down because I know it opens down. And I'm going to do that in both directions. Then I go back to that starting point and I move over 2 and I go down 4. Back to it, over 2, down 4 on the other side. Again, go back to the starting point, 1, 2, 3, and then down 9, puts us right here, and do it on the other side, puts us right here. Okay, so that's how you get you can hopefully see that that's going to be a parabola. Now we have to connect those points, and so we do have to go back to this, and this is going to tell us whether or not we're going to connect those with a dotted, or dashed if you prefer that, versus a solid line. Okay? It does not include equal to. So think of it like the circles when you graphed on your number line. If it was equal, then it was a solid circle. You closed it in. If it was not equal to, then it was dotted. So sometimes it's easier to draw a dotted. I kind of missed that. Fix that. So do that. Make sure you know that it continues. It does not stop at those points that we put And good thing my daughter is not that good. Okay, so the next thing that we have to decide is whether or not we shade above or below. Okay, so what I'm going to tell you about that is this is a shortcut method, and I'll talk about it every time we do one, and that is if y is by itself on the left side of the equation, then you can look at whether or not y is less than or greater than. And if it's less than, then you shade that region that is less than, I don't want to say less than because you know that. Let's go with below. Below your y-intercept. Okay? And if it's greater than, then you're going to go above your y-intercept. Okay? So we're looking at ours. It says y is less than. So I go to my y-intercept, and the region that is less than is the region that's inside the parabola. Okay? It doesn't ever stop at wherever that y-intercept is. I had some people do that. This is going to be either inside or outside, but we're using that y-intercept to help us decide. So I'm going to shade inside my y-intercept. Inside my parabola, because that's the region that is below the y-intercept. Okay, so that is part A. That's what's involved in that. Now, the next thing we're going to do is part B, which says let y equal to 0 and solve for x. So if y is equal to 0, then it looks like 0 is less than negative x squared plus 4. Okay? And what you have to think of is this is my graph, basically that dotted parabola. And they want to know where is the graph greater than 0. Well, what kind of numbers are greater than 0? We've talked about that a lot. Those are positive numbers. So where is the graph? Where are those values positive? And so what we have done in the past is covered up the bottom part of our graph because we know that's negative. This is the line where it's equal to 0, and this is where it's positive. Okay? But what you're going to do, the easiest way to do this, okay, when you're doing this part B, if I say let y equal 0, solve for x, and graph the solution, okay, what I want you to think of, I did not want to do that. What I want you to think of is, let's go with this one. No, this one. All right. Oh, poo. I need a skinny one. All right, that's the x-axis, right? So if I take that x-axis and I move it over here, okay, then all I have to do is take those points off of the x-axis, okay? What are the points that I had? I had a circle on -2. I have a circle on +2. They're not colored in. They are on my graph because I was using them to graph, but it's a dotted line, so that's like an open circle. And then the part that is in my shaded region is that part that's in between. So that's the part that I'm going to shade. Okay, so all I'm doing is taking this, because that's in my shaded part, and transferring it over there to an x-axis. All right, and from there, we're going to solve for x, and so you just write your algebraic statement from here. We've talked about this is an and statement because it's a segment. So x is greater than -2 and less than 2, or x is between -2 and 2. So the last question says, explain the relationship between the coordinate plane graph and the number line graph. My students had no trouble. They said the number line graph is the x-axis, which is where y equals 0. The number line graph is the x-axis from the coordinate plane graph. So I kind of was showing it to you when I did it the first time. We graph it on here, and then we take that part that's shaded, we take where it intersects, and we move that over to the number line, and we shade exactly where we shaded on our graph. Okay, let's do another one. Turn your paper over. graph y is greater than or equal to, and again, they were able to tell me, okay, what shape this is by looking at that equation, and that's the point of our parent function packet. So this is your absolute, and I can't spell. Let me change that. Let's go here. Absolute value function, which they knew that looked like a V, just like value, okay? It has that bottom point, which is a vertex of 0, 0. And the other thing we wrote on our parent function packet was m was equal to plus or minus 1. And what that means is this has a slope of 1. So when you get this point, you go up 1 over 1, up 1 over 1. That's 1, and that's negative 1. And if it's anything other than 1, there will be a number in front of your absolute value. Okay? So then we look at our graph and we say, okay, negative 1, everybody knew it went to the right. And negative 2 meant that it went down. And so I'm going to go plot that point. So that's my new 0, 0 point. So from 0, 0, I go right 1 and down 2. Okay? And my slope is 1. So up 1 over 1. And remember, what's important is where it crosses the x-axis. So from there, I just want you to fill up your graph. I'm going to go up 1 over 1 in both directions. That's the plus or minus. And then I'm going to keep that pattern so this one will go that far. And now I am going to connect those to make that shape that we have. Okay, and I didn't really pay attention there. Oh, pooh, I did not mean to do that. Okay, stay there. Come on. All right. Come on. Oh, I got you. All right, let's keep going here. And then I have the other piece, okay? I didn't stop to check first, but it is right here. It's solid. I mean, excuse me, it's equal to, so that's why it's solid. Now we have to determine whether we're going to shade inside or outside. So when we look at that, y is greater than my y-intercept. So greater than my y-intercept is going to be, let's go look. This is my y-intercept. Greater than goes this way, so that means I'm shading everything that's inside the parabola. I mean, not parabola, excuse me, my absolute value function. So I'm going to go shade that. Okay, and now we have graphed it. Okay, and yeah, it's okay if you keep going that way, yeah. Okay, so let y equal 0, solve for x, and graph the solution. So basically what you want to do is take that number line, take your x-axis, and copy it over to the number line. So where did I intersect? I intersected at -1. I intersected at 3. Are they colored in? Yeah, it's an equal to up here, so yes, it is. So I'm going to color those in. And then when I'm looking at that x-axis, did I shade in between the two of them? I did. So that's my answer. And how do I write that algebraically? X is between -1 and 3. Okay, explain the relationship between the coordinate plane graph and the number line graph. Okay, so what is that relationship? As we said before, the number line graph is the x-axis, which is where y equals 0, from the coordinate plane graph. Okay, so the last thing that I did with them, and I talked to them because it leads into the next lesson that we have to do, is I went back to this first problem, and we talked about what does that look like? What is the graph of it going to look like? Excuse me. So let's go with this. Graphing 2x minus y equals is less than 6. So what is it going to look like? Well, they were able to tell me that it was going to be linear. Okay, it's of our parent functions. It doesn't have any special symbols. It has no exponents. It doesn't have any absolute value signs. It doesn't have a square root symbol. So we know it's linear. It has an x and a y. And this is a different form that we haven't talked about this year. Ax plus by equals c. Okay, and the other thing that I told them about, if you weren't in class, you might want to know this, is I referred them to IXL, Algebra 2, Lesson D.7, because D.7 is something that will help you review all the different ways to graph lines. And it does tell you the best way to graph this one is to do something called using its intercepts. And if you don't remember what intercepts are a point that crosses an axis. So 0, if 0 is x, then it's going to cross the y-axis. If 0 is y, it's going to cross the x-axis. So you're going to have some kind of number here. So what we did is we took, I told them, okay, if I go put 0 in for x, then I'm left with negative 3y equals 6. So y equals negative 2. So I have the point 0, negative 2. And I can graph 0, negative 2. Okay? And then if I take that thing and move it over here to get rid of my y, then I am left with the equation, the same thing, 2x, don't do that. My bad. Let's go back to that. 2x equals 6, so x equals 3. So that gives me the point 3, 0. So I plot that. So if you can see, sometimes that will fill up your whole graph, and that's all you need. But we're going to see if we can put more points. So if I start here, I would go up 2 and over 3. Up 2 over 3 takes me off the graph, so you don't have to do that. But if I start here, then I go down 2 and to the left, and down 2 and to the left, so that puts me right here. And that was as much as I did with them because I wanted them to do the rest of it. But I really wanted to make sure that you knew where you could go to earn some easy bonus points and brush up on graphing lines. So that's the end of U1 Lesson 10. Please come see me or email me if you have any questions. Thank you very much.